Bismillahirrahmanirrahim. Can you all see the screen? EE163 Computers and Programming Live Lecture 02. Okay, excellent. Okay, let's get started. We have to discuss a few things today. This is our lecture 2, and I hope everyone can hear me clearly. I'm going to do it really. So, I'm going to cover the topics really slowly. So, if I just speed up, so let me know in the chat window. Okay, the first few things I need to cover is the slides, some work fields for computer programming. In the previous lecture, we discussed that what could we do if we learn computer programming. There are a few more fields I need to discuss, such as automation. By automation, we mean that anything which can be done by machines and for greater efficiency, and if you want to get the work done by using some kind of robotics. So there are a few kinds of automation, such as industrial automations. We have product manufacturing or pharmaceutical product manufacturing or lab or something like that. And we have transport, such as automated cars, and online retail is essentially warehouses where you need to assemble a few products for delivery. And then we can have some communication and productivity apps, such as we are using Google Meet or any other software. So in terms of automation, if you can see this picture, this is from a Tesla factory, which makes electrical cars. And there are lots of robots out here which are assembling cars and doing steps which were primarily done by humans before. But since humans can work for like 8 hours a day, but robots can work like 24/7, and they have much more precision. So that means that in these robots, there are lots of computers which are working, and there are lots of motors and as well as lots of sensors. So those computers are actually reading the data from those sensors and guiding those motors to pick up some few items and assembling them on the cars. They have some welding robots, they have the painting robots as well, they have the placement robots as well. And if you can look closely, this is a well-known company of industrial robotics, something known as KUKA, KUKA. If you can go to their website, kuka.com, kuka.com, you can see how those robots are actually used in all of these cases, such as they are also, this KUKA company robot is also used in this lab sample automation, where you need to sort out some few lab samples. Obviously, these robots can do much faster work than humans, and a time has come that in some factories that there are very few humans actually working, but a lot of robots are working over there. So that means that if somebody is looking for work in a factory or something like that, those jobs are actually diminishing. The actual jobs or actual work which is being done is in the design of these factories and the manufacturing of these robots. So and the time will come that in some future, that robots will actually develop even more robots to manufacture more things. So you need to keep that in mind. So if you can learn computer programming, that means that you have a step on the ladder to learn how these autonomous robots actually work. And if you can actually design these robots. And in Pakistan, there are lots of factories which are not automated. And due to this pandemic situation, we are not so sure whether humans would be allowed back into the factories or whether the workflows would be same as before. So it's much more likely that a lot of these jobs would be taken up by these robots, and these industrial robots are pretty much the future, whether anyone likes it or not. Another field is the transport. We are talking about the automated transport. We have the autonomous cars already, and they actually work on the LiDAR. That's LIDAR. That's, I think, light detection and ranging. Which has some kind of a 3D scanner with a laser scanner, and it just monitors where every other objects are. And behind the scene, a lot of deep learning or deep neural networks actually work to figure out where um, deep neural networks where they actually work behind the scene to figure out how the cars should drive. Once again, it is actually dependent on lots of computer programming, and that programming is not static. That programming, since it's a learning network, that programming actually changes as time goes along. So you're not changing the actual code, you are making the computer to learn itself and develop its own neural networks to better understand the world around it, and to perform the given task. Such as if you're driving a car and you want the car to be autonomous, that car would be taking in the data, lots of data from lots of cameras and the LiDAR, light detection and ranging instrument, and it will be figuring out where the car wants to go, and it will be controlling the servo motors, which will be controlling the steering wheel and the accelerator and the braking pedals, and the and some other things in terms of engine performance as well. So this thing is another field for autonomous vehicles. And the next thing is the online retail. I mean, this thing is actually big. I mean, if you have seen the past few days that lots of retail companies actually, or lots of retail outlets were simply not open, but the online shopping was available. And this is pretty much the, if the situation is as it is, as in this pandemic situation, this is pretty much the end of retail as we know it. There might be some retail shops remaining, but the actual shopping experience would be pretty much online. And we would have, and we I still do have, if you have seen the warehouses of this well-known online retailer Daraz in Pakistan, and if you, and these are the pictures from the Amazon warehouse somewhere in their countries. They have like billions of merchandise items stacked on these shelves, and these simple robots actually pick up these shelves and get them to the actual user, because there are no robots right now which can actually pick the items and place them into the box, because you have like a three-dimensional shelves over there. So what these robots actually do is they actually pick these shelves and they bring those shelves to the humans, which actually pick these things and place them into the box depending on what the users have ordered. um, that means that, I mean, after this picking, after the filling up these baskets go to these packaging things, and that's where the majority of these workers actually work. So I mean, behind the scene, these robots were what shells they have to pick and in the most efficient manner. And I mean, they have some really good cloud based algorithms, and they actually work and improve over time, so that they can improve the time to the consumer. That says the consumer has ordered few things and he or she wants that them delivered in 24 hours. So that means that every second they save in picking up these items is actually helping the product to reach the consumers in less amount of time. So there are, I mean, obviously, if you can have like 10 robots, and you have got like 10 pathways in which these robots can actually move into these directions, you already have 10 factorial combinations in which the robots actually move. So I mean, there is a need of algorithms which actually learn along the way that what is the most efficient um way to go for these robots, and what is the shortest distance from, let's say, from this point to this point, and how it would move to and avoiding collisions as well with the other robots as well. So I mean, that's another example of the automation which is going to be, because it's essentially the next industrial revolution is already happening right now, and computers will play a really pivotal role in this automation revolution. And some few things you need to learn with computer programming, because this is a really basic course over here. Something, because the actual uh, if you are a retailer, you probably need to move online, because we are not so sure whether the retail shops will actually open again or not so sure, because if you're a retailer, you need to provide some um, virtual experience for the users so that they can try on your products virtually without actually moving to the shop. Another thing which is actually business to consumer, we call that B2C systems. Another thing is the B2B systems, business to business systems, in which you will be providing your services to the factories or the manufacturing concerns to automate their systems. So you need to learn the embedded systems, which are essentially microcontrollers or small computers, which use the very same C++ programming inside them, or Python programming. I mean, the syntax is a little bit different, but behind the scene concepts are same. And then you need to learn robotics and instrumentation. By instrumentation, I mean, how can you read the sensor data so that the robots can perform the task correctly. So obviously, robotics, and we mean by manufacturing those robots and how to control those servo motors, or maybe those stepper motors if they have stepper motors in them. So, and you also need to learn artificial intelligence, such as deep learning or deep learning neural network, something like that, because the code which you would write is not going to be static. It's not going to be like that. It's not never going to be changed. It is going to be changed. And the best way to change the code, or best way to change the programming, is through learning networks, in which the robots get better over time performing the task again and again. So you need to, I mean, just like a child learns how to do a particular task, so less in a similar fashion, these robots running deep learning networks or deep neural networks behind the scenes will actually learn how to get the things, how to get those things to do, or how to perform the actions in a better and better way. So these are the few more motivations in which, I mean, these things are actually coming. So I mean, if you are going for the electrical engineering part, your whole grid is actually going to be automated. So I mean, all the relays, all the protection devices, all the generators, all the loads, actually is even the loads connected to the factories, as well as the storage capacity, they are going to be automated, because the human reaction time is actually very slow. And if you are going to financial trades as well, if you are into the markets of stock exchange as well, the stock trading is actually done by computers in much quicker fashion. Humans simply cannot match them. So I mean, lots of fields, I mean, computers are the, uh, s- one of the pivotal forces in our ecosystem. So we need to learn how these things actually work. Okay, coming back to our course, there are a few queries that what kind of exam question we would be covering in this C++ course, computer programming. There are actually 4 or 5 types of exam questions. There is one is how write a program to do something. You would be just like if we did in lecture number 3, 4, and 5, in which we did some practice problems. I mean, similar to that, you would be given some some problems to solve, and you need to write the code on the paper. And then there is some question that you would be given a code, and you would be asked to find what are the errors in the code. So I mean, you should know how the compiler really runs. I mean, you should know the behavior of the compiler, and you should be able to figure out some syntax codes or some logical errors in the code. So you need to point those out. And there is another type of question that you are given a code, and you are asked that what would be the output of this code. Without running the code, actually you need to figure out what the output of the code would be, performing some logical calculations in your head. And then there would be some logical questions, such as what would be the value of variable n after so many iterations. Let's say if you're running a code after like 10 times, you want to know whether some variables are changing some values, and what would happen after the code has run 6 times. We will see this type of question whenever we would be doing loops in which we want to run the code again and again. Then there are some MCQs and true false questions. They are essentially some, basically we're dealing with the lectures number or the recorded lectures, in which we would be asking whether something is true or false, or what. And you would be given a code, and you would be giving some like 4 outputs, and you have to select which output actually fits that. Or you would be given some numerical problems, which we will be discussing in lectures number probably 7, 8, 9. Okay, so I think no problem so far. Okay, so moving on to the next few remaining things from lecture 3. There is something known as declaring using variables. I did not cover that in the previous class, where you have to keep in mind that variable names, the identifiers, they should be not from the reserved keyword, and they are case sensitive. Once again, C++ as a whole language is actually case sensitive. You cannot start a variable name with a number. You can start them with an underscore, and they can contain letters only and numbers only, not special characters or not space or anything. Uppercase and lowercase are distinct. So this thing, my value and my value, are different, which I've explained that in lecture number 3. I mean, these are bad examples. You cannot start with a number. You cannot have a space in there. You cannot have a dash. I mean, this is not an underscore. You can have an underscore in a variable name. You cannot use class, struct, or while. I mean, these are keywords in C++ language. You cannot use them as variable or identifier names. And there was a question that parse the following program identifying all the keyword. I mean, how would the compiler look at this code? That's what we mean by that. So that, I mean, compiler would actually just ignore the white spaces or the blank spaces, and we need to figure out what are the keywords, identifiers, operators, and literals. So before going into that, keywords are, they are the some type of some object or entity. Let's say if I write integer a, so int is a keyword, and a is the name or name of that integer, which we known as identifier. I mean, we need a name to identify something, so in this case such an integer. So I mean, keywords, I mean, identifier can be function names as well, identifier can be variable names as well, identifier can be object names as well. So let's see. So if we have main, this is the name of a function, so this is basically an identifier. Int is a type of that which the main function is going to return the value. So basically this is a type, so that means int is a keyword. Here this int is a keyword, and n is an identifier because it identifies a variable n, but the type is int, so this is a keyword. So I cannot write int. I mean, I cannot name an integer int, because int is a reserved keyword. Cn is an identifier because it's a function. Let me check. Yes, cn is an identifier, and n is also an identifier because it identifies something. Cn actually, if you call it a function, let me check. No, you cannot call it a function, but it's an string manipulator, but it does a function. It does something which takes an input from the user and assigns it to value variable n. This n is an identifier, and this thing cout is an identifier, and endl is also a function which I mean, essentially a string manipulator. Actually it inserts a new line character, and it also does one more thing which some student has asked, is flushes the buffer. Actually, whatever you are typing in the computer, or whatever the computer is outputting to the screen, is actually in a stream. Actually, I mean, whatever is coming on the screen is actually in some kind of a stream. You want to flush out, you want to clean up that whole stream, you use endl, so that whatever new things comes up, that will be displayed in the next line. So it does two things in one thing. I mean, for starters, just take it as endl just inserts a new line character. You can just place \n over here. So operators, I mean, they do perform some operation. So we have, I mean, these things, these round brackets, these curly brackets, they are the, I mean, the round brackets, they are the function call identifiers. Oh, sorry, function call operators, whatever. I mean, whenever you have some round brackets, think function. Whenever you have some curly brackets, think blocks of code. So, and this thing, I mean, this is an input operator, and this thing is multiply equals to, actually means equals to and multiply by 3. This is also an operator which performs a function, which performs some operation, not a function, sorry, that whatever the value of n is going to multiply with 3 and assign it to back to n. And this thing is n equals to, this thing is a literal. Literal means you can have a string literal if you have more than one character, some kind of a sentence, or you can have a character literal in which we have just one character. You can just enclose it in a single quote. So I mean, these are the, which are the remaining things from the lecture 3. And from lecture 4, we did the escape sequences. So I mean, if you want to print these, I mean, if you want to print some single quotes or double quotes, escape sequence means that whatever is coming up next after this backslash, not forward slash, but forward slash was for division. After the backslash, whatever is coming up next, we are telling the compiler just ignore it. So it's going to print whatever is coming up next. So I mean, I've explained that in a lot of detail in lecture number 4. So I hope there is no question from that. So it's really simple if you want to if you want to print these things. From lecture 5, important thing is, do not leave variables uninitialized. If you leave them uninitialized, I mean, they would be assigned to some memory in the, I mean, if you declare a variable, that variable would be assigned, actually that would be, that variable would be occupying some memory in the computer, and that memory might contain some values which were written from some previous processes. So I mean, they could have some garbage values. So whenever you are declaring a variable, always initialize it. Just for example, if you have written integer a, all, I mean, if you plan on to using that integer later on, I mean, you can just declare it and initialize it there and then. You can just write integer a equals to 0 semicolon, so that you're 100% sure that a has the value 0 and not some other garbage value. Cn used to take to input from the user using the input operator. Cout is used for the output. For the console output, we have used that very often. Okay, Arslan Ahmed, sir, please explain the, I mean, that was the only question I got from the, I mean, I actually posted on the classroom.google.com that if you have any questions, ask them in that in this that chat window, or not in chat window, ask them in the classroom.google forum, and I will explain that. That was the only question from Arslan Ahmad, sir. Please explain the enumeration program with more examples. So I'm going to explain that in a moment. So if I can, let me get over here, and I want to, I'm just stop present in a moment and present now a window. Can everyone see the C++ window? That can everyone see the can everyone see the dev C++ that include IO stream and so on and so forth? No. Still no. Okay. What can I do over here? Okay, let's check it again. Still no. Okay, I'm going to stop presenting. It's kind of a working. Okay. Now I get it. So screen one. Okay. Can anyone can now? What about now? Okay, excellent. Okay, Jazakallah. Okay, so what I'm going to do is before discussing the enumerator type, I have written all the code which I need to discuss, but I have commented that code. That means the compiler is not going to run, is not going to see all these commented lines, as compiler is not going to run. First thing I need to do is I'm going to, I mean, just for my own hints. So what I need to discuss, I've written that over here. I'm also going to comment these lines, and I'm also going to comment these lines. So that means all of these lines are essentially yellow in color, and they are commented, or that means we are, and the compiler is not going to run it. First thing I need to discuss is, let's say if I want to declare a variable integer a, and if I do cout and I write value a. That's it. And if I run this code, I have declared it, but I have not initialized it. That means that it's going to put out some garbage value. It's not necessary to put out 0. If you run it again, it might have some different value. So let's just, I mean, I did not initialize it, so it might print some garbage value. Okay, so no problem with that. Now, if I do this, if I write constant integer a, and if I do this, it puts up an error over here. The reason is that if you are declaring a object, I'm not saying a variable, it's actually a variable, but variable by definition means the value which can vary. But now I am saying that it's a constant variable, so it becomes some kind of a misnomer to understand. So just think it as an object a, and it's a constant value. The important point of this constant value is that it has to be initialized, or the value of this a object has to be known at the time of declaration. That's extremely important. That, let's say if I write constant integer a, but I did not initialize it, is going to put an error over here. So if I write it integer a equals to 10, is going to be okay, because that's going to put out the value um, 10 over here. So no problem with that. Now, the important thing is that constant numbers or constant objects must know their value, what value they are going to hold at the time of declaration, or at the time of at the time of their declaration, or time, that's it. If I do this integer, sorry, a equals to 20, I'm overwriting it. I cannot do that. Had it been something like this, I mean, I cannot overwrite a constant value, but if I delete this constant identifier, if I run this thing, I can do that. The initial value was 10, but I've overwritten it to 20. Now it's outputting the value 20. So I hope no problem is there. Okay. Sir, please the semester example. Yes, I'm going to explain that in a moment. Okay, just bear with me. We have lots of time. What is that? Abdul Muiz pin karo screen, no screen. Bhai screen ko pin karo. Okay. Coming back to that's the first thing we need to figure out. Okay. If I take the input, let's delete that, and I'm going to uncomment it. I've just typed it so that my lines are there. Okay, constant integer a, and see what happens over here. Let's delete this line, and let's delete this line. So if I've declared a variable a, but I haven't used it yet, so that means I'm going to modify my, let's run this code first and see. That means that I cannot I mean, I've declared a constant, but I cannot use it because I have not um, initialized it. So constant integer equals to, let's say if I declare a variable integer. So I think that the user would be, sorry, the compiler would be really happy running this thing. So I've declared a variable a, and it says enter a value of a. I just write 5, and the value of a is 5, and that is going to be printed over here. No problem with that. Now, if I do, I mean, that's a simple integer. So if I do constant integer, constant integer b equals to a. So that means by the time this line occurs, the value of a would be known, and that value of a would be assigned to b. So that means at the time of declaration, the value of b would be known. So that means that if I write b over here and print out the value of b, so that would work, because at the time of the declaration, I have the value, I mean, sorry, I just press 3 over there, enter a value of a. That means a is initialized to 3. And then I assign this value 3 to constant integer b. That means at the time of this declaration, declaration means we are declaring that we are going to use a constant which has the value of b. It says the value of b is 3. 3 is printed over here. I mean, there's some statement over here. You can just write anything. So this 3 for the value of b is printed. So I think it should not be a problem with any of the users. Okay, so that means that constants need to have their value declare need to have their values initialized at the time of their declaration. That's important. But enums are actually also constant. So let's go to this example. So please explain enum type. Yes, I'm going to explain that. So okay, I'm going to declare an enum enumerated type. Enumerated type means, enumeration means actually a number list. That's it. But we use this data type behind the scene. This is just an integer. That means if I write, I did not write, I'm going to explain that. I did not write anything for fall, spring, or summer. Fall contains the value 0. Spring contains the value 1. Summer contains the value 2. If I write fall equals to 2, that means spring will contain the value 3 and summer will contain the value 4. But if I write spring equals to 4, that means fall will contain the value 0, because by default it starts at 0. But now spring is 4, that means summer would be 5. So that, I mean, the next value. I can also do this, that summer equals to 8. That means fall would be 0, spring would be 1, and summer would be 8. So no problem with that. I mean, but there is some but behind the scenes, they are actually integer constants. So let's say if you want to have some kind of a variable and you want to declare them as integer, and you want them to have a limited set of values, you probably would want to use an enumerated data type. I mean, I could have done like this. If I do not want this to happen, I could have done like this. Let's see. If I have declared a semester, and this is my own cell data type. Okay, I mean, behind the scene, just an integer constant. So that means it can have 3 values: fall, spring, or summer. And let's delete this 8 to avoid this problem. And let's say I have declared 3 variables of type semester. That means that s1 is of type semester, such as if we just do integer a, b, c. I mean, a is type integer, b is also a type integer, and c is also a type integer. So that means that semester s1, s2, and s3 are all, sorry, s1, s2, and s3 are all of types semester. And s1, let's say if I just copy paste the whole thing. If I do this, s1 equals to fall, s2 equals to spring, s3 equals to summer, and I see out the whole thing, actually I probably, yes, okay, no problem with that. So if I just see out the whole thing, that means it's going to see out 0, 1, 2, because behind the scene they are just essentially integers 0, 1, 2 without the spaces, because it did not insert the spaces. You want to, you can just put these single quotes between them, something like this, and the space bar, and that's it. I mean, if you want to put a spaces, you can just put a spaces over there. So I'm not going to deal with that in a moment. Okay, so that means that s1 here, if I could have written something like this, I'm going to comment this line. If I write constant s1 equals to 0, constant, oh sorry, constant integer s1 equals to 0, constant integer s2 equals to 1, constant integer s3 equals to 2. I mean, these things, I mean, these three lines and these three lines means exactly the same thing, but there's a difference. Since I've declared a constant, that means I need to assign the value whenever I'm declaring it. Okay. But here, if I mean, if I just comment these lines, let's comment this line as well. I have declared these variable names and I know behind the scene they will be containing some constants values, but I did not initialize them. I can initialize them later. That's one difference between enumerator and the enumerator data types and the constant integers. I mean, you can just declare them and assign them values later on, but you cannot. I mean, for constant, you need to assign the values whenever you are declaring the constants. So that's one difference. Another thing is I cannot take the input. I mean, if I write, so this is 1, 2, 3. I mean, if I just need to compare. Um, out is there. So if I write, let's delete these lines or let's comment these lines because I'm running out of time. So I'm going to comment these lines and here. Can I take the value for an integer? That's a problem here. Can I take the value for S1? Because I mean, naturally, I would want the user so that I would want the user to enter some value. And I would take a look at enter the value for your semester, and I want the user to type spring or summer or fall. I cannot do that in C1 over here because S1 is a constant, and I mean it simply doesn't work. If I just press S1, it's going to put them an error over here because I cannot take these input from the user and assign it to S1, even though S1 can contain value of 0, 1, 2, but I cannot do that. S1 can, because I mean, it simply CN simply doesn't work this way. So this thing is an error over here. I need to assign the value. If I write S1 equals to 0, let's run this thing. Error. Reason is that if I want that program to assign the values to these variables in this limited set of possibilities, I cannot assign any other value. But however, I can assign, instead of assigning 0, even though behind the scene this is 0, I can do this. S1 equals to fall, no problem at all. Okay, the program just ran as it is. Okay, and S1, S2 equals to summer, or S2 or S3 equals to spring, I can do that, no problem at all. Another thing is that if I want to, I mean, it's not necessary. If you want to use enumerated data types, you can use it. If you do not like them, don't use them, no problem at all. Because I mean, if you have so many names, it's hard to keep track that what names are used where. So let's say that the last thing I need to discuss is that if I want to take the number integer a, if I want to take the input from the user, there are two ways. Abdul Muiz Qureshi. So enumerators are working like constant integer by using different keyword. Yes, but constant integers can have any value. But enumerators will only have the values which you have defined in these two curly brackets. That's the answer to your question, Abdul Muiz Qureshi. Good question, but I mean, the only three possibilities are allowed for the type of the object of type semester. Not any other keyword or any other name or any other value is simply not allowed. I mean fall behind the scenes is 0, but I cannot even assign 0 over here. I have to write the word fall. Similarly, I cannot write S2 equals to 1, even though behind the scene it is 1. I need to write spring over here. Okay, the last thing I need to discuss is let's say if I want the user to enter his or her semester. So there are two ways to take the input from the user. Either you can take them as numbers, but the best way to take the input from the user is make them type a string of characters, and then you just write a program to figure out what those characters actually mean, and then guessing or maybe equating that to some other things, and so that you can figure out what the user actually typed. But here you cannot take the input from the user and assign that value to S1, S2. However, if I take the input, let's say if I take the input integer a, enter your semester number, and I'm expecting the user to, I mean, fall is 0. Okay, fall is, I mean, that's the number 1 over here. Fall is 0. So if I write into enter your semester number and the user has typed, let's say 0, That means I'm checking whether 0 is equal to 0 over here. Then I would write your semester of fall and so on and so forth. I cannot take the input because we haven't done the strings library yet. I cannot take the input as fall, spring, or summer. I can only take the input as 0, 1, or 2 because I've defined it as such. So if I run this code, see out your oh sorry, I think there is some, okay, that's comment. Okay, see out your semester is not running. Is there some error? Let me check. यहाँ पे report window, id return 1, exit status. Okay, let me comment the lines because I've done lots of comments over here, and here all the comments. Integer a, enter your semester number. If a equals to fall, your semester is fall. Return 0, so it should work, but it's not. Let's delete all these things. Not so sure where the error is. So enter the semester number and L, and Cn is integer a. If a equals to fall, I mean this should work, and this should work. And if let's say there is no problem over here. Nope. Okay, let's figure it out. Be some error which I have not. C out and value of a, and let's see if I, sorry, if I comment this line and if I comment this line, there might be some error. I'm running out of time. There's like 3 minutes remaining, and can anyone tell what error I'm making over here? There might be some error. C n equals to this. C out of this is that. There might be some error in my def C++. I'm not so sure whether it's actually for. Okay, let's see the floating report window. Oh, sorry. There is some exe file open behind the scenes. I cannot overwrite that. I need to. Actually, I'm running out of time. I'm going to recontinue from here. There is some exe file running behind the scenes. I'm not so sure whether that. Okay, can I rerun this thing? There is some exe file, but I cannot see in my task manager. So there might be somewhere. I'm going to recontinue from this point onwards, but you get the whole picture from here. I'm going to run the same program or maybe post it in a simple video because there is some exe file error behind the scenes over here. So don't go anywhere. Let me take the attendance. So before taking the attendance, is 114 students are here. Don't go anywhere. I need to take the attendance. So just keep online. Okay. So one more minute. Okay, attendance has been done. So just hang up and leave the meeting. And I will see you inshallah on next Tuesday. Before doing that, just see lecture 7 at 9. Allah Hafiz.